First of all, problem number 3 is 1969 AB 17, not AB 16. And we're asking for points of inflection here. So we know if we want to find points of inflection, the first thing we need to find is y prime and then y double prime. So y prime is 20x to the third minus 5x to the fourth, and y double prime is equal to 60x squared minus 20x to the third. And if we set y double prime equal to 0, we see that y double prime equals 0 when I'm going to go ahead and factor out a 20x squared. Actually, I'm going to factor out a negative 20x squared, and I'm going to get negative 3 plus x. Okay, sorry, I think I may have done that a little bit too much in one step, but nevertheless, we see that when x is equal to 0, and when also x is equal to 3, we see that y double prime is equal to 0. Does that mean we have a change in sign on both of those? Not necessarily, so we always have to check that. Let's check 0 and 3. Okay, so when we check 0 and 3, we get to the left of 0, if we're looking at this as our y double prime. Okay, I should have put equals 0. If this is our y double prime, then when x is equal to some sort of a negative number, we get, the first term is always going to be negative. This is going to be positive. So we have a negative times a positive, and then negative 3 plus some other negative number is going to be negative. So on the entire interval for x values of negative, we see that y double prime is positive. In between 0 and 3, we can take a, let's say, a test value of 1. Again, the first term is negative, second term is positive, and then negative 3 plus 1 is also negative, so we see that y double prime is positive on that interval as well. So we have concave up, y is concave up, first interval, y is concave up, second interval, and then when x gets bigger than 3, we can see that y double prime is negative times a positive times a positive, and therefore y double prime is negative, making y double prime negative on that interval from 3 to infinity. Therefore, we only have one inflection point, and I was kind of looking at these y values, and we only have one x value of 3, so the only possible option would be B for that. I don't need to plug 3 in. I'm confident that when x is equal to 3, y is equal to 162. It's the only option, but many of you may have picked D, but D is no good because 0 is not in fact an inflection point because we don't have a change in concavity there at x equals 0. That's the sucker answer. Sucker answer. Don't fall for the sucker answer. Now, it's okay on your homework to fall for the sucker answer because you're just learning, but on the test, there's always going to be a sucker answer, and that's a trap. So don't fall for the trap. Sucker, I shouldn't call you a sucker. I'm calling the answer a sucker answer. Okay, so just understand. I'm trying to help you learn to not just go for the first thing you see, and be a little choosy here, and do the work necessary to determine that here we have only one inflection point. Hope that helps.